Hello everyone. In this video, we will see how insertion sort algorithm inserts every element into its correct position in the sorted part of the array. So as you can see, this algorithm over here, the first line of the algorithm is nothing but the function definition, which consists of the four parts. One is nothing but the return. Return type is void. This means the function does not return any value. Then the next part is the name of the function. And the third part of the function definition is nothing but the parameters. So over here we are passing two parameters. The first parameter is nothing but the array, which is containing the unsorted input elements, and the second parameter that we have passed is the total number of elements in the input array. And the fourth part of this definition is nothing but the body of the function. Okay. Now the next line in the algorithm is nothing but the loop. This for loop, it starts with the index 1 because the first element at the index 0 is already considered as sorted one. The loop continues until the last element in the array, and during every iteration one new element is picked from the unsorted array and it is inserted into the already sorted portion of the array. So over here, uh, the next line is nothing but what? We are storing the first element in the unsorted array in some variable, that is x, because while shifting the larger element to the right, we would otherwise lose the current element. Now then the next line over here, the j points to the element immediately before that of the x. Okay. This means j points to the last element in the sorted array. Now the algorithm compares x with the previous elements one by one. Next, inner for loop. This is the heart of the insertion sort. The loop continues while the two conditions are true. The first condition is j greater than or equal to 0. We should not move out of the array. Then the second condition is if the previous element is greater than the current element, then we should move one position to the right, as this algorithm sorts the array in ascending order. So in every iteration, j is decremented by 1. For example, consider we have these 5 elements: 8, 5, 3, 9 and 1. Over here, as per this algorithm, a of I is initialized to 1, so value of I is 1. Now after that, a of I we are copying into x, so a of 1, okay, so a of 1 is nothing but this 5. So this 5 we have copied into the variable x. So value of x becomes 5. After that, we are initializing the j to I minus 1. As the value of I is 1, j is initialized to the 0. Now within this loop we are checking these two conditions. So now j is greater than the or equal to that of the 0. Then it will check the second condition, whether a of j is greater than x or not. So a of 0, that is 8, 8 is greater than that of the 5. So as this condition, both the conditions are true, what we need to do is we have to move one, shift the element one position to the right. So a of j, that is this 8, we are copying into the a of j plus 1. So this element will come over here. Okay. So now a of 0 as well as a of 1 both will contain the element 8. Now after that, again the control will come to this for loop. It will decrement the value of j by 1. Now the new value of the j becomes minus 1. Now it will check this condition. So this condition is not satisfied. J is not greater than or equal to 0. So this loop terminates. After termination of this loop, the next statement that is getting executed is nothing but this. Assign the value of x to a of j plus 1. So what is the value of x? 5. And that 5 we have to assign to whom? J plus 1. So as the value of j is minus 1, so j plus minus 1 plus 1 will become 0. So at a of 0th index, we have to assign the 5. So now 5 will occupy this position. So after the pass 1, here the pass 1 ends. So after the pass 1, the output that we are getting is this. Here, as you observe, the first two elements are already the sorted one, and in the unsorted array, there are three elements. Now we will repeat the same process. Now during next iteration, control will go to the outer for loop. The value of I is getting incremented. It becomes 2. For that value of I, j is again reinitialized. So value of j will become 1. Okay. And now it will compare these two cases, these two conditions. Now over here, as j is greater than 0, so a of j, that is nothing but 8. So this 8, this 8 will get copied into a of j plus 1. So over here it will come. Okay. Now after that, the value of j is getting decremented. The new value of j will become 0. So now as the new value of j becomes 0, x, that is 3, is getting compared with the a of 0, that is 5. Okay. So 5, as this 5 is greater than that of the 3, so again we will shift the element. So this 5 will occupy this position. Okay. 5 will occupy the next position. Now the content of the array will become 5, 5, 8, 9, 1. Again the value of j is getting decremented. It will become minus 1. So as it becomes minus 1, this condition is not satisfied. Control will come out of the for loop and the value of x is assigned to the j plus 1. So as the value of j is minus 1, so value of x, that is 3, is assigned to j plus 1. So now this is the output of the second pass, which will act as an input to the next pass. In the next pass, what will happen? The value of I is getting incremented. It will become 3. The value of j is reinitialized to 2. Now the new value of x becomes 9. So over here, as the 9 is not 9, 8 is not greater than that of the 9. So over here, both the conditions are not satisfied. So control will come out of the for loop and the value of x is assigned to j plus 1. So 9 will occupy its own position. So over here, if you observe, there is no shifting if the input is already sorted 1. Okay. Now during next iteration, the value of I is getting incremented. It will become 4. The value of j is initialized to 3 and the value of x will become 1. So over here, again that 1 is getting compared with 9, then 8, then 5, then 3, and then it finds its appropriate position. So it gets placed at the index 0. Okay. So now if you observe, we got all the elements are sorted over here and the loop terminates because we have sorted all the elements. Now so in this way, the elements are getting sorted using the insertion sort. Now if we see the analysis, the best case is nothing but what if your input is already the sorted one. So in that particular case, there will not be any shifting. So the time complexity in that case is big O of n, where n is the total number of elements to be sorted. In the worst case happens when the input is in reverse order. So in that particular case, we have to compare each and every element and shift each and every element. So the time complexity will be big O of n square, and the average case time complexity will be big O of n square. The space complexity is nothing but the space required for the algorithm to complete. So over here we require only two extra memory spaces, that is the space required for storing the value x and for storing the value j or the variable j. So the time complexity is the constant one. Now to summarize, how we have done the insertion sort is, we are starting from the second element, store the current element in the temporary variable, compare it with the previous element, shift the larger elements one position to the right, insert the current element into its correct position, and repeat until all the elements are sorted. So insertion sort is simple, stable, and works efficiently for small data set or nearly sorted arrays. That's all. Thank you.